Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Atiqah binti TAJULMAR and my supervisor is Dr. Muhammad RABIUL. And today I'm going to present my final year project, which is titled Pipe Crack Tracking Using Guided Acoustic Waves. So first of all, I'm going to start with a brief overview of what is pipe crack tracking. The piping system has become one of the most essential parts of a well-developed community. When we talk about pipes, or when someone mentions pipes, the most general uses of pipes that people can imagine is the one that connects um, water or fluids from one place to another place. Like the most common example of pipes are the water pipes that we have at home. And these pipes generally they connect our sink or our shower to the water source, and also they transport our waste product from our toilet to the water treatment center. And but one of the biggest revenues that the piping industry made is not from these water pipes that are being installed in our neighborhood, but actually one of the pipes that are being installed underground, the subsea pipelines for the oil and gas industry. And this is because one of the biggest use of pipes are to transport elemental fluids like petroleum and gas underground for the oil and gas industry. This kind of pipelines, they transport a huge and large amount of petroleum and gas in a very vast distance. And the one that I've read about in most articles, there are almost like 72,000 kilometers that are being installed in the USA alone from the year 1952 to 2017. And they are not just being installed in a very, very long distance, but they are also being installed in a very incredible depth into the ocean floor so that they can actually reach the source of the petroleum. So naturally speaking, these pipelines, they are exposed to extreme natural environment that could potentially damage the pipes. And because of that, the manufacturing of the pipe, they takes into consideration the diameter and length of the pipelines, the operating pressures, the subsea terrains, the submarine environments, and fluid characteristics. But even when all these technology are being developed to maintain the pipes, there are still some factors that could potentially damage the pipelines, include the production of the pipelines, which is maybe there's some kind of error in the manufacturing of the pipeline itself. And then there's man-made force, which is oftentimes are fishing equipment from fishing boats. They are being dragged in the seabed. So it could potentially damage the pipes when they make contact. And there's also natural environment, which comes from ocean currents. Ocean currents can actually corrode the soil that are underneath the pipelines, and this could potentially cause the pipeline to bend and eventually snap. And there are also corrosions. And corrosion in most cases happens inside of the pipes itself because the petroleum and gas, they are being transported in a very high speed. So there could possibly be some kind of friction that eventually will lead to corrosion. So these damaged pipelines, they will cause incidents like oil leaks and explosions. And even in some article, they said that oil leaks and explosions is kind of like the byproduct of the business because of how inevitable the incidents are. So in order to overcome this situation, there are a lot of methods of inspection that are being developed to actually ensure that these pipes are working in a top conditions. And one of those methods are electric field mapping, which basically they use two electrodes and they put one electrodes on one end of the pipes and another electrodes on another end of the pipes, and they will run a electric current through the pipes, and they will calculate the voltage drop between these two electrodes, and the voltage drop will tell us if there is any kind of anomalies on the surface of the pipe. And there are also magnetic flux leakage, which is basically the same method with electric field mapping, but instead of using electrode and electric current, they use magnetic field. And there are also sonar mapping, which is using sound waves. There are other types of inspection method that I didn't mention here, which is also using robots. Examples, transportation using underground pipes are crude oil pipes, petroleum product pipes, gas distribution pipes, and gas transmission pipelines. So the hypothesis of our project is to detect a crack on a pipe and implement an early warning system using guided acoustic waves. So the scope of our study is to develop a system that utilizes guided acoustic wave signal with flexible piezoelectric sensors and vibrational sensor that detects cracks on pipe. And the coding of the system that we will make will be using Arduino software. For the problem statement, number one is that we have no early warning system that was implemented based on guided waves to warn us about anomalies on the surface of the pipe. And the characterization that detects and defines the shallowness and severity of the crack on the pipe also are not available for guided waves. So that will lead us to our objective, which is to develop an early warning system that could detect anomalies on the surface of a pipe by using the Arduino-based sensor, and also to successfully define and characterize the severity and shallowness of the crack on the pipe by using guided acoustic waves. Now we are moving on to our methodology. I'm going to give a brief overview of how this project is executed and the brief overview of the process. A replica of a pipe with different types of cracks are prepared for the different types of results. And this is because we need to actually replicate different types and size of shallowness of the crack or severity of the crack itself. That's why we need to use a different kind of pipes. There will be a few more than two kind of pipes that we're going to use here. So first, the vibrational sensor is put on one end of the pipes, which is then connected to the power source. And another sensor, which is the piezoelectric sensor, will be put on another side of the pipe. The piezoelectric sensor will be connected to Arduino Uno, and the Arduino Uno is connected to the power source and also SD card. So the way it works is that the vibrational sensor will emit signals that will then be received by the piezoelectric sensor, and any kind of data on the signal will be stored, will be processed in the Arduino Uno and then stored in the SD card. So this is our flow chart. We start here, and then the vibrational sensor will emit signal, which then will be received by the piezoelectric sensor. And then the signal will be sent to Arduino. The Arduino will process data, and the data is saved on SD card. And this process will actually be on loop as long as there are power source to supply current to the circuit. And then we will manually handle to analyze the data, and then we will detect the crack and define if the crack is severe or characterize the crack, and then we reset the system and it's back to the start. And if there's no types of crack, the system will also reset and back to the start. These are the components that we will be using. Number one is Arduino. Arduino is the open source electronics prototyping platform based on easy to use electronics hardware and software. So normally the Arduino, they come in two, which is both the hardware and the software. And in this project, we also use both the Arduino software and Arduino hardware. There are many types of Arduino hardware, but in this research, we are using the Arduino Uno. This is the picture of the Arduino Uno. And then the next component is the flexible piezoelectric sensor. The specific type that we use in this project is the LDT0028K. And the function for the piezoelectric sensor is to receive the emitted signal being sent by the vibrational sensor. And the next components that we have here is the vibrational sensor. So the specific type of vibrational sensor that we use is the analog piezoelectric ceramic vibration sensor. So this sensor will emit a vibrational signal that will be received by the piezoelectric sensor. So the vibrational sensor emits signal, and the flexible piezoelectric sensor will receive the signal. So moving on to the expected result. In this segment, we are going to talk about the specific applications and commercialized business potential for the project. So the specific equation is that this project will propose a high functioning inspection method to lower cost. And this is because, as we have discussed before, there are a lot of types and method of inspection, but most of them are very costly, especially if the company is using robots. So using sensor is actually a lower cost option, and it also will minimize human resources. For commercialization and business potential, the oil and gas company may resort to a cheaper method of inspection. And this is because there are two types of oil and gas harvesting. There's onshore oil and gas harvesting, and there's offshore oil and gas harvesting. So the way people are actually, a lot of companies, they are actually, it's more preferable to harvest oil and gas onshore, on land, because it's much safer. It's reachable by emergency services if there's anything happen. But the most important thing is that it's less costly, because for offshore, for them to operate in the middle of the ocean, they actually have to build rigs and platforms and stuff like that. So the rigs and platforms, they cost almost around $500 to $1 billion. So this company will like try to find or resort to a cheaper method of inspection because of how costly the project itself. And then the problems that may arrive in the middle of the project is that there are no broken pipes being sold. And because we need to initiate or replicate cracks on a pipe, there's actually no kind of broken pipes being sold online or in shops. So the solution that I propose is that the pipes will be manually broken by me. And the next problem that we have is that the sensors might not be working properly or maybe they are damaged. So the solution that I propose is that a backup sensor is prepared. So this is our Gantt chart. The research proposal presentation are all held in 2020, but the system design, circuit design, the system development, and the final project documentation writing will all be start in January 2021. So that's all from me. Thank you.